So hello my friends, now that I have brought again for you my channel, that is Ritu's Academy, and we have to continue the last chapter what we are continuing, that is covalent compound. One part already I have uploaded. If you're not seen that, kindly do you have to go and you have to see that. You need to do the revision for that. And now I have brought today the next part, the next video, and that is part B, in which we will cover the topic that hydrocarbons, and what are the three types we have: alkanes, alkenes, and alkynes. So let's start now. Hydrocarbons. Now hydrocarbons we have, that is, there are two types of hydrocarbons, and mainly saturated and unsaturated. But before that, let's understand what are hydrocarbons. Its name already suggests you that hydrocarbon means the compound in which only hydrogen and carbon we have, right? So what are the compound you find in which only the carbon and hydrogen you found? Those compounds are known as hydrocarbons. Now if you just see the two you can say broad category for hydrocarbon, that is saturated and unsaturated. Saturated, in which all the compound, we can say atoms of carbon atoms in that carbon hydrocarbons and all. So you will say all are having only single bond. There is no double bond, not a single double bond you'll find here. You will only all the elements which are connected in hydrocarbon, they all are connected through single bond only, through single covalent bond only. So those compounds are known as saturated hydrocarbons. And if you see the alkanes come under this category, because alkanes, the general formula for alkane is what? That is CnH2n+2. Means C here stands here carbon, H stands here hydrogen, Cn, that is means how many number of carbon atoms we do have, and H2n+2. So whatever the number, if you know the n, you will put in the formula, and accordingly you can find out how many carbon atoms and how many hydrogen atoms will be there in that particular alkane, in that particular hydrogen hydrocarbon or saturated hydrocarbon. So we have to see the first example, that is methane, in which one that carbon atom we have. And so if you put in the formula CnH2n+2, you'll find that the carbon is only 1 and the hydrogen we have 4. So you can see, as we have done in the previous video, that carbon is tetravalent. Tetravalent means you have to satisfy 4 valency. And how will you do that? You will do by satisfying, means the carbon should satisfy its 4 valency, but means 4 elements should be attached in that with single bond. So the 4 carbon atoms are 4 hydrogen atoms are attached with 1 carbon. On the other hand, if you see the ethene is C2H6, because the next member what comes in alkene family, that is ethene, and that is C2H6. So 2 carbon, and as you can see, they are satisfying the valency of carbon, that is tetravalency, and by doing so, you will see that to each carbon 3 hydrogen are attached, because one part, that is 1 valency, satisfied by both, means by, you can say, each of them, the carbon they're also attached to each other with a single bond. So that's what is C2H6, which is satisfying in the formula. Which formula? CnH2n+2, this formula. Then we have unsaturated hydrocarbon. Unsaturated hydrocarbons in which not a single bond, but you find out any one or even more than that, this double or triple bond, right? Triple covalent bond if you find between 2 carbon atoms. So those categories, if we have double bond, those are known as alkenes. If we have triple bond, then we call what? That is alkynes, right? So alkenes having the formula, that is CnH2n. CnH2n. N, you have to just put the number n, and accordingly you can find out how many carbon and how many hydrogen attached to make that particular you can say compound. So let's see an example, because the carbon can have double bond, carbon hydrogen can't have double bond. So that's why the first member will not be methane. Methane doesn't exist. So the first member comes in the family, that is ethene. So when you put in the formula, C2H4 will come out by using the formula. I'm repeating again, that is CnH2n, right? So can you see that how the tetravalence is satisfied here? So between the carbon and carbon, the carbon should have four, you can say elements should be there, four bonds should be there. So only to each carbon, only one hydrogen is there, means where are the two bond now? The two bond between carbon and carbon, you can see. So both carbon are satisfying four, you can say, valency, the first, you can say tetravalency. Let's see one more example, that is propene. So propene means three carbon we should have. So our formula will be three C3 that H6, and wherever each of the carbon, you can see each of three carbons, they are satisfying the valency, four valency. The first C is having only two hydrogen because the two that valency two bond is shared by first two carbon, and so on. Accordingly, we'll say there should be four bond only, and you can easily make it out by seeing in the formula example. Now, unsaturated only, they doesn't only deal with double, but they also deal with triple covalent bond between carbon and carbon. So those compounds having triple covalent bond, they are having the alkynes, right? They're having the alkynes and have a triple covalent bond between two carbon atoms. So the formula will be CnH2n minus 2. Okay, I'm repeating. CnH2n minus 2. Kindly you have to you have to recheck the video so that you can write the formula. So whenever you just find out, you can see like first example, because they will be the double or triple bond, we can find only between the carbon and carbon. So methane and methane doesn't, we don't have these two. So the family starts from, you can see when the carbon is 2 in number, and so ethene or ethyne starts. So ethyne, that means a triple bond between carbon and carbon, and accordingly they are just only one hydrogen carbon, one hydrogen atom is supposed to attach to satisfy the valency. And so on, you can see the example of propine also. Propine means 3 carbon atoms we will have, right? Okay, let's move further. Now, what is that? Isomerism. That is means you have some compound of, you can say hydrocarbon, or you can say some carbon compounds you have, and you are making the different structures. The molecular formula same means number of carbon atom, number of hydrogen atom will remain same. They will not change, but the arrangement of such, the compounds, you may change it. You are presenting in a different way, right? Suppose we can say we have, agar hum koi dish try karte hain, you have to go, so you will find the different flavor. That is means, if you are just you people like anything, you people like you can say cheese, paneer, or you can say chicken, whatever you people like it. If you try it in different restaurant at home, so you may find some different taste and all that. It's a different structural formula, but although that is the same material we are using in that, same kind of stuff, spices and all, we are using that. So same way, you are having the different, you can say same molecular formula, but different structural formula you will get, and those compounds, they are known as isomers. So this property is known as isomerism. And let's see the example, like we have started with the example butane. So butane formula, that is alkane family. Alkane family, the formula will be what? CnH2n plus 2, right? So the formula will come C4H10 will come. Okay, now we'll see that how with the same number of atoms, how can we present it into two different forms, right? So they can say normal butane, you can see over here, that is normal 4 carbon in a chain you people have put it in, just satisfy the carbon valency of each of the carbon atom, and then 4 valency you have to satisfy, and accordingly hydrogen you will attach. Now let's try something else, that you just try to change the structure and all. What you will do, that, or what you'll do, 3 carbon in a chain, and the 4th carbon is you can say in the you can say below the 2nd carbon. Can you see over here, the arrangement has been changed. The arrangement has been changed. So this is what call, if you just name it, that will be, if you're numbering it 1 2 3, that will be 2-methyl propane. So either you call it butane, the number of carbon atom and hydrogen atom in butane, and you can say 2-methyl propane, the number of carbon atom and hydrogen, they are same, but structures are different, and that's how the formula will also become different. Or you can say simple isobutane also, you may call it. Let's see one more example, like that pentane. So C5H2L again is satisfying the formula for alkene. And so as means higher hydrocarbon you choose, so आपको उतने ज़्यादा isomers मिल जाते हैं, right? So the second one what we have, that is pentane. So पहले वाले में देखो आपको एक मिला था isomer, एक normal था. सेकेंड वाले में एक नॉर्मल पेंटेन है, दो उसके आइसोमर्स मिल गए हैं. सो दैट विल कैन से दैट मींस दो उसकी न्यू फॉर्म मिल गई है. सो नॉर्मल पेंटेन सिंपल 5 कार्बन एंड सेटिस्फाई द वैलेंसी. एंड देन आइसोपेंटेन पहला कार्बन आप सेकेंड वाले पे लगा दो, सो इट विल बी 2 मिथाइल ब्यूटेन. सो आपको एक नंबर कम हो जाता है, पेंटेन से ब्यूटेन पे आ गए, ब्यूटेन से प्रोपेन पे चले जाओगे. फर्स्ट वाले केस में क्या था, ब्यूटेन था, ब्यूटेन से एक कम किया तो कहां पर आ गए आप, आप प्रोपेन पे आ गए, राइट. तो एक कम हो जाता है, पर वो ग्रुप जो होता है, एक कार्बन हमने कहीं ग्रुप में लगा दिया, जैसे हमने बोला 2 मिथाइल, अभी मैं आपको फिर 2 मिथाइल बोल रही हूँ, तो वो 2 मिथाइल तो आपने अलग कर दिया, लेकिन और वो उसका चेंज जो था पेंटेन से ब्यूटेन बना दिया, और उसको एक उसका कार्बन ऐसा ग्रुप अटैच कर दिया, राइट. सो दिस व्हाट द वे हैपन. एक और कर लो, क्योंकि मैंने बोला जितना आप बड़ा चेन उसको बनाओगे, लेके चलोगे, उतने आइसोमर ज्यादा बना पाओगे, उतने डिफरेंट स्ट्रक्चर ज्यादा बना पाओगे. थर्ड एग्जांपल देखो, दो उसमें एक और, एक पहले से लगा दिया, सेकंड पे एक और वो लगा रहे हैं, उसके नीचे एक और लगा रहे हैं, एंड दैट यू कैन से 1 2 3. सो हियर आपने चेन और छोटी कर दी, पेंटेन से पहले ब्यूटेन पे आए थे, ब्यूटेन से आप प्रोपेन पे चले गए हो, लेकिन वो जो ग्रुप जो हटाए उसका भी तो कुछ करना है. So that you can say 2 dimethyl, एक ऊपर मिथाइल ग्रुप है, एक नीचे मिथाइल ग्रुप है, तो it will be 2 dimethyl propane, and so on. You can say that, right? So these are the examples how to make the isomers and all. Now very interesting topic, that is the functional group. The functional group are those, an atom or a group of atom which when you attach with the hydrocarbon, the whole property become change. उसके नाम पे ही property आ जाती है. Like you can say alcohol, which group, OH group we have. अभी आपका OH ग्रुप है, आपने यहाँ पे लगा दिया, what will happen then? अभी वो क्या था जिसको आप अभी ब्यूटेन और प्रोपेन जो भी आप उसको बोलते, आप क्या बोलोगे, आप उसको ब्यूटेनॉल, प्रोपेनॉल, पेंटेनॉल, तो वो उस OH ग्रुप की वजह से नाम पूरा हाइड्रोकार्बन का चेंज हो गया, because now it is a family of alcohol group, that's why. So let's see some of such functional group. The first is halide, halo groups, that is chlorine, bromine, iodine, and when you attach in a chain, so alkene name remains same, but only as a prefix you attach it. So you can say chloromethane, bromomethane, और जो आपका जो ग्रुप लगता है, सॉरी जो एटम लगता है आपका, क्लोरो, ब्रोमो, आयोडो, जो भी आपका लगता है, that comes, you can say that is replacing one hydrogen. जैसे आपने मीथेन का फॉर्म लिखा CH4, so वहां पे एक हाइड्रोजन को रिप्लेस कौन करेगा, क्लोरीन कर रहा है, so that's why it is chloromethane. So it is not CH4, it is CH3. वो जो एक H आपने हटाया, उसकी जगह पे क्या है, क्लोरीन आ गया. So that is what the difference you can say. The next is what you can say, bromoethane, because यहाँ पे आपका क्या था, 2 कार्बन वाला चेन आपने यूज किया है, right? So that way you can do it. The second we have alcohol, that is OH group. The similarly when you are attaching the OH group, that will become the alcohol family. So methanol, ethanol, propanol, so on. The third is aldehyde. Aldehyde is CHO. In CHO, you will just say that C and H having a single bond, and C and O, CO के बीच में डबल बॉन्ड आते हैं. तो आई होप यू डोंट बी कंफ्यूज इन दैट. अभी यहाँ पे क्या देखो, यहाँ पे बहुत चीजें समझने की जरूरत है. आपका जो CHO जब आप लगाओगे, यही आपका एक ग्रुप, मतलब यही आपका एक नाम है. मिथेन अगर जब बात कर रहे हो, मिथेन का मतलब है एक कार्बन, ऐसे नहीं C लगा, CH4 है, आपको एक H हटा के CHO लगा दोगे, तो वहां पे तो 2 कार्बन हो जाएंगे. तो वो मिथेनॉल कहाँ से बता, मतलब वो आपका मिथ कहाँ से रह गया, बिकॉज मिथ मतलब 1 कार्बन. अब वो एल्डिहाइड का अपना है, तुम्हारा अपना है, वो इट डजंट मैटर. सो व्हाट इट हैपेंस, सो डोंट बी कंफ्यूज हियर, दैट इज मेक आप इसी को एक लेगोगे, कुछ उसके ग्रुप में ही कार्बन है, तो यू हैव टू इंक्लूड दैट कार्बन आल्सो, यू कांट रिमूव इट, राइट. तो आप जैसे आप ब्यूटेनॉल बोल रहे हो, तो ब्यूटेनॉल का जो एक कार्बन होगा वो ये एल्डिहाइड का होगा, 3 आपने लगाए हैं, तो वो जब 4 बनेंगे, ये नहीं कि 4 वो है और एक आपने ये भी रख दो तो 5 बन गए ना. You will not do that, right? So that's why if I'll talk about this methanol, that is CHOO, and one place is empty, so you will just attach one H, so that will become HCHO, methanol. Similarly, ethanol, that again CHO, आपने CHO यहाँ से हटाया, और एक जो यहाँ पे, because it is ethanol, H, तो 2 कार्बन होना चाहिए, फिर आप एक कार्बन लेके H को सेटिस्फाई करो. So that way you have to do it. ओके, कार्बोनिक एसिड सेम वे, यहाँ पर भी आपका है ग्रुप में ही कार्बन है, जैसे एल्डिहाइड में ही कार्बन था वो इंक्लूड होगा, इट इज अ पार्ट ऑफ दैट चेन, इट इज नॉट एज अ ग्रुप, इट इज अ पार्ट ऑफ दैट चेन. सो मींस इट इज अ पार्ट मींस दैट कार्बन इज आल्सो टू बी इंक्लूडेड. ओके, उसको आप अलग से नहीं, आप उसको यू कैन से ट्रीट करोगे. सो दैट इज COOH, कार्बोक्सिलिक एसिड. एंड सिमिलरली COH है. अभी आप बोलोगे COH में एक C के साथ एक तो OH ग्रुप है, कैन यू सी ओवर हियर, एक C के साथ OH ग्रुप है, OH सिंगल बॉन्ड से लगता है, और जो दूसरा O है that is making the double bond with O. So how many bonds are satisfied here? 3. अभी कितना, एक जगह बाकी, क्योंकि 4 चाहिए हमें, तो यहाँ पे एक H लगा दोगे तो that makes the formula HCOOH, that is methanoic acid, oic acid, because आपने कार्बोक्सिलिक एसिड लगाया है. एल्डिहाइड में क्या आता है, अल की वॉइस आती है, अल्कोहल में ऑल की वॉइस आ रही है, मिथनॉल, इथनॉल. एल्डिहाइड में अल, मिथनल, इथनल. कार्बोक्सिलिक एसिड तो ओइक एसिड यू विल ऐड, सफिक्स लगाओगे, दैट इज मिथनोइक एसिड, इथनोइक एसिड, प्रोपेनोइक एसिड, एंड सो ऑन. And next group we have, that is ketone group. In ketone, the carbon and oxygen have the bond. Again, जो लास्ट की तीन, अगेन आई एम रिपीटिंग, तीनों में कार्बन है, दैट विल बी मेकिंग अ नंबर इन हाइड्रोकार्बन चेन. ठीक है, वो ध्यान रखना, उसको अलग से मत ट्रीट करना, तो योर नंबरिंग विल बी रॉन्ग. सो दैट इज CO मींस, CO मींस डबल बॉन्ड O के साथ लगता है, हम पहले भी बात कर चुके हैं ऊपर वाले दो में. सो दो ऑलरेडी लगे हैं, दो की जगह खाली है, तो आप वहां पे 2 H लगा दोगे. ठीक है, तो मिथनॉन बना दोगे. ऐसे आपका क्या बना, यहाँ पे CO लगा है, CH से CH लगा, मतलब आपने डिपेंड जितने कार्बन एटम लगा रहे हो. तो प्रोपेनॉन, देन वी हैव 4 ब्यूटेनॉन, 5 लग जाओगे, लगा दोगे, पेंटेनॉन, and so on. You will just increase the chain because that is a catenation property, you can say that makes the big, long chain. Okay, the next we have, that is homologous series. Now homologous series, as we have seen the number of example, alkene, alkene, alkyne, saturated, unsaturated compound हमने पढ़ा, अभी हमने ग्रुप्स पढ़े हमने. तो आप कोई भी एक ग्रुप की फैमिली उठा लो, आप अल्कोहल की उठा लो, एल्डिहाइड, कीटोन, कोई भी उठाओ, एक फैमिली उठाओ, बट एक सीक्वेंस में उठाना, एक सक्सेसिव मेंबर्स होने चाहिए, ऐसे नहीं कहीं से बीच में से नहीं, सक्सेसिव नंबर होने चाहिए, with carbon 1, with 2, with 3, with 4, with 5. When you will write the formula for all that, consecutive numbers के साथ जब आप उसको बनाओगे, and you will just find that series, what will happen, you will see over here that you will find the difference between the two consecutive members of that family. चाहे वो कोई भी फैमिली है, वो नॉर्मल आपकी हाइड्रोकार्बन है, वो आपका कोई ग्रुप, फंक्शनल ग्रुप वाला है, whatever you find out, you will always observe there is a difference. वो जो डिफरेंस होता है, वो कितना डिफरेंस आता है, दैट इज CH2 ग्रुप. अगर आपको ऐसी सीरीज मिलती है किसी भी फैमिली की, किसी भी हाइड्रोकार्बन की, इन विच यू आर फाइंडिंग the difference between two consecutive numbers is two consecutive members in that series is CH2, that will make a homologous series. Now let's find how. मीथेन में देखो CH4 है, ठीक है, सेकंड वाला इथेन में C2H. अब मुझे बताओ दोनों में कार्बन कितना डिफरेंस है, 1 का, H कितना डिफरेंस है, 2 का है, तो CH2 का हुआ डिफरेंस. बाकी नेक्स्ट में आ जाओ, CH इथेन एंड प्रोपेन में, तो फिर से 1 C and 2 हाइड्रोजन का, एंड सो ऑन. So this is what how it makes the difference, right? So that way this is a homologous. Let's see more example. Now we have alkenes में भी देख लेते हैं, because I said कोई भी चेन होगा वो सेम आपको फॉलो कराएगा. So आपने इथीन, प्रोपीन, ब्यूटेन की फॉर्मूला लिख लिया as per the formula, that is CnH2, and what I told you in the starting of the video. So अब फिर से देख लो, कार्बन के बीच में, हर एक कार्बन के बीच में 1 का डिफरेंस है, हर एक हाइड्रोजन के बीच में 2 का डिफरेंस है. That again makes 2 CH2, you can say difference, right? The same you people have observed in arithmetic progression also in grade 10. You people have done one chapter maths. So what you do, the common difference in the series, you find out that common difference is here. That is only the common difference that you make it as CH2 group. You can say that means group is different between two consecutive numbers. So last example, you can see alkynes. Alkynes here the formula CnH2 and -2. So accordingly, 3 members they have written C2H2, C3H4, C4H6, ethene, propyne, and butane. And again, you find out दोनों consecutive के बीच में एक कार्बन और 2 हाइड्रोजन का डिफरेंस, right? So this is how you can make the you can make it out that homologous series में, और अगर आप किसी ग्रुप का भी उठाओगे, जैसे मैंने बोला एग्जाम्पल उठा लो, मिथेनॉल, दैट इथेनॉल, प्रोपेनॉल, ब्यूटेनॉल, ठीक है, कोई भी उठा लो, या फिर कीटोन का उठा लो, you can say that propanol, butanol, pentanol, कुछ भी उठाओ, कहीं से भी उठाओ, दो कंजुगेट के बीच में हमेशा CH2 का डिफरेंस होता है, any group. So that was in this video, that much. And so thank you so much again for your support. But as I always tell, I need your support. Kindly spread it. And I need your support. Keep spreading, keep sharing, keep learning. And do comment that what more videos you want to learn. So all the best. And thank you so much. We'll see you soon.